Okay. All right. Yeah, thank you for having us. I'm Nate Springer. I run the worldwide engineering team here at Bitglass. I'm located down here in Georgia. I was paired with with Brad down here in the Southeast, and now my responsibilities have expanded a bit. So I now run the team globally. I started IT back in the 90s, got into solutions engineering mid 2000s, around 2007, with a company called Spirent Communications, Bitglass or Breaking Point, and Ixia. Did a lot of security testing there, got some certifications, certified ethical hacker, worked on a lot of things there. Moved into the wireless space when wireless was a big thing, working on a lot of NACs, firewalls, things like that. With a company called Xeris. Xeris was then acquired by Riverbed. And while at Riverbed, we were put on the team with wireless and SD-WAN. And, I saw SD-WAN as a vehicle to really kind of my vision around SDP, software defined perimeter, right? So I think we all know what software defined perimeter is today. It's really just ZTNA or private access. I had some visions there, and they didn't quite have the same vision. So they didn't really want to go down that road. So moved on to Arrowhive for a brief stint, and then landed here at Bitglass, and been here at Bitglass for about 2 years now, and excited about what we're doing, where we're going. And I'll present today basically, our vision on CASB, but how that vision is basically changing a little bit, as far as it's really this conversation is turning into more of a SASE, right? So everybody's talking about this term SASE, secure access service edge. It's really just an umbrella statement or framework that incorporates multiple technologies like CASB, Secure Web Gateway, ZTNA, Zero Trust Network Access, SD-WAN, and things like that. So I'll be presenting that. But before I do, I'll let Brad introduce himself quickly, and then I'll jump in and we'll get going.
Cool. Yeah, thanks, Nate. So I'm Brad Armstrong. So I'm the sales director for essentially what is the Southeast. Have known Nate for quite some time. So very, very sharp engineer, very forward thinking, and glad to have the opportunity to talk with you all, and glad to have Nate share some of his insights too.
Awesome. All right, cool. So really, in summary, before we get going, I'm not going to present too many slides. I'm not necessarily a slide. I'm not a fan of slides. So I do have one or two here specifically, and they're really kind of geared towards how to have this conversation, right? So just identify the use cases, understand what they are, and then we can talk about those use cases, how to solve those use cases, really, what does CASB actually mean in this space when we look at what our problems are that we have in front of us. And so, taking this diagram here, it's very simplistic, but it tells a pretty large story, right? Really on the left-hand side, you're talking about the access to all your applications. Prior to this, that question mark would typically be, VPNs or some type of access to your data centers to allow you to have access to your applications that were only accessible on the VPN or within your four walls. Internal apps, managed apps, and even internal resources or services outside of maybe just SSH, RDP, FTP, things like that. And so when you break this diagram down, you can build several use cases here, and so a couple of them that you don't necessarily see, because now as we've kind of moved this everything over here on the left, as it's moved out to the cloud over these past several years, the data that was behind our four walls in our data centers now moving into applications like Office 365, Salesforce, Google, things like that. And now that data is, because it's there, we have to transition our thought process on how to secure that data, right? Because people are trying to access it via their managed device, which is fine, but they're also trying to access this from unmanaged devices. Plus you have the threat of credentials that could potentially be exposed to, different, hacker networks and, dark nets, things like that. And how do we protect against all of that? And so as we transition to securing these applications that are now moved out to the cloud, your users are also no longer inside your four walls, maybe not even on your VPN, accessing these cloud resources and applications from multiple types of devices. A couple things that aren't necessarily, visual here is, there are some protections. So when Bitglass talks about CASB, we talk about it with a term called multi-mode. And that mode really just means making sure you have security in multiple modes around, let's say, APIs, right? So a lot of these applications, and not all of them, provide API security. So you can hook into their APIs, scan the data, and gives you multiple things that you can do to identify, maybe loopholes, security holes, maybe data that has sensitive information in it. How do we, protect that or quarantine it? So you have your API hooks into all of these applications. Well, not all of them, but most of these applications. So the nice thing about APIs is it doesn't require any user interaction. It's very easy to set up, and that's the nice side of it. The bad side, though, is that API is not the full story, because there is, there's a limitation as to how many calls per second an application can have. So you're limited based on the size of your organization. How often do you have to call on that API to get this job done? And if you're in a large organization during busy times, you will have a delay, as you're rate limited by these applications. There will be a delay before a scan could actually take place. So that could cause some issues. And furthermore, not every application here actually has security-focused APIs. So one in particular is Workday. So Workday in particular is, they may be building them out now, but over the last few years, they do not have security-focused APIs to tie into to get done necessarily what you need done. So you have to look at other modes now to protect this particular application. And so going from APIs, we may now look at a mode where we're going to do something more in line, like a forward proxy. So you could potentially, because you own these devices, the managed devices, you put an agent on those devices, or if the device is on-prem stationary in your network, you may use a pack file or something like that. But either way, you want to send that session data through a forward proxy to do inspection, utilize the DLP, inspect what that user is doing within the application to put limitations around it and protect that data from that perspective. So, you have APIs, you have forward proxy, and then lastly, you have reverse proxy as well, because in a lot of conversations I have out there, and I've heard this over the last couple of weeks, where a lot of people didn't realize there was actually a solution that could solve unmanaged devices accessing their G Suite, for example, right? So they've been struggling with, how do I prevent, or how do I even secure someone using their personal device when they access my G Suite or whatever application it may be. It doesn't even have to be these core applications either. It could be an application that's very vertical specific to your organization. There is not only that, there's also the unmanaged device isn't necessarily just a user that's within your organization trying to use their personal device. This also is, if you break down unmanaged devices, we're talking about contractors, third-party vendors. We're talking about people who potentially need access that we haven't distributed a managed device to them. So how are we going to allow them to access our data and still protect that data? So there's a lot of thought around that, and there's a lot of things and it's not necessarily just the data itself as far as what you want to prevent them from downloading. Now that we're allowing someone accessing our applications, we also have to take into consideration the device they're on. We don't know anything about it. We don't know the posture of that device. That device, for all we know, could be vulnerable. Someone could have, potentially root access to that device, or something could be happening to that device where, if they start to move data from their unmanaged device up to your applications that your users are using, what if they introduce a file that has potentially malware in it, or something that could lead you to a potential breach, or some other scenario. So, the reverse proxy, we have to look at that scenario in a few different ways. So the upload of malicious content, and then preventing the download of data as well that we don't want to lose and prevent outside our four walls. Furthermore, there's as we kind of talk about these use cases, we're going to step on things like internal apps, which there's terms out there called private access, right? So everybody has their XPA, right? So whatever the X is, their private access to this internal application. So there's multiple ways to do this as well. So you can do this in a agent-based scenario. So you require the device, the agent to exist on that particular device, which will then give them access to that internal application. And then there's an agentless version as well. So you may go to a portal and click on a tile inside of a portal that will take you to that, and not necessarily require a VPN to do this. So you have your internal apps and resources. Where we start to kind of get into the SASE is when we start to talk about not just the internal apps, but internal resources like RDP, SSH, things like that. So now we want to zero trust, or we want to apply zero trust to that, either that device or that user as they try to access these internal applications. So zero trust network access really is about really, instead of opening up a VPN a chunk of the network via VPN to these users, we can be a little more surgical and precise and say, okay, user, using this ZTNA, we will allow you to RDP to this specific IP, or is this specific server, or this bank of servers, whatever it may be, but you're only going to have access to those resources. There's no need for you to try to look for other resources on the network to basically try to access. You only need that one particular piece. So again, this part really is kind of straddling the CASB, ZTNA, private access type scenario. So there's that. And then another use case I see here as well is web and unmanaged apps, right? So this is a big one. So a lot of people talk about this, and this really consists of multiple things. So I'm sure you heard the term shadow IT. So shadow IT is understanding, what's happening on that device or within your four walls, and reporting it back to a system that can look through those logs and identify risky applications. Maybe stuff that you didn't know or aware was happening, and your firewall maybe wasn't telling you about that, or wasn't identified. So we want to look for that, take the logs and parse through those logs, identify them, and not just see what they're doing or see what, risky apps they're accessing, but take action on that as well. So if we have a scenario where we have an agent out on the managed devices, and we identify a risky application and it falls within a certain category, we may actually, update that agent to say, hey, agent, I need you to start blocking a particular app because I was unaware that my users were going there. So, there's correlation between the shadow IT piece here and potentially this is kind of as we talk about the agent, it's a little bit of forward proxy, and you're also talking about secure web gateway potentially as well. Also mixing in the DLP engine in here as well. And I'll show you a couple of use cases because I think it's easier to talk about when you see things happening. And so I'll show you where we kind of have, we're mixing and talking about secure web gateway, forward proxy, and utilizing the power of the DLP engine to identify things and prevent things from happening, because we don't want this data that's on this device to land in these unmanaged applications that we have no visibility into. So, that's definitely a big use case. So, kind of in a broad term, kind of looking at the whole thing here, to support something like this, if you really think about what we're going to do here. So if I have users coming in on a managed device accessing these, how would I actually get in the pathway, get in line, do that? It's going to require a proxy type scenario, proxy resource. And so you have to have a platform that's going to be able to scale and grow to that and allow the user to have a good user experience, get their job done, but still provide that security and really kind of protect them from things they may not understand that they're doing, right? And I'll show you a use case in that before we jump over to the to my other platform here. I have another machine on here that has the agent. We'll show you kind of the unmanaged device and the managed device and different accesses here. And as I'm going through these, if anyone has questions at all, feel free to jump in and ask. We can talk about, I can answer any questions along the way as well. And I'm just bringing this up primarily because the idea is that it really depends on the fabric that you are putting this session on. So we have to have proxy. You have to forward and reverse proxy. You have to be able to support the load. You have to be able to grow with the load. It has to be elastic, right? And it has to be available and very close to the end user. So it's very important to have the footprint globally, right? So, here at Bitglass, we have, about 300 points of presence globally because we've taken advantage of AWS and we're not building out data centers ourselves. We're not trying to compete with the AWSs, the Azures, the GCPs, all those out there that are doing this, and this is what they're very good at. We want to utilize their technology and their all their tools that they give us on top of this fabric and build our platform into it to scale, as we need load and as the system requires it. So really, I just really want to just kind of preface what I'm going to show you here with those slides. Again, if anyone has any questions as I jump into a couple of use cases, kind of show you, feel free to jump in. So first, I'm going to talk about, I'm going to jump, since I'm on this device, I'm going to do a scenario where you could have a contractor or a third-party vendor accessing one of your applications, right? So someone goes to, and I'll just use office.com, very common. Most people are using office.com. So coming to office.com, you don't want to change the user's experience. So again, the user is going to come here and do what they normally do on an everyday basis. And it could be this, or it could be they go to, I'm integrated here with Okta. So maybe they go to the Okta tile page and they click on the tile in Okta, which brings them to Office 365. I mean, that's an option as well. So the whole idea here is to offer the ease of use, the user experience, and don't change anything for that end user. So I'll show you what it looks like. Oops, don't need one of those. So your general login experience is going to be identical across the board, whether I'm on a managed or unmanaged device. And so this is a managed application, Office 365. And I'm going to log in here on a device that doesn't have an agent, an unmanaged device, but a trusted user. So I do have an account. And you'll notice that without having installed any software or anything like that, I'm now transferring the session to go through the Bitglass reverse proxy, the Ajax VM. That's really, this is now within the AWS infrastructure that I just mentioned. So we're on that low latency access and that low latency network that's built within Amazon itself. So some of the things we want to be able to prevent in this scenario is potentially the upload of files from a device we don't know. Sorry, there it is. We don't know the posture of this device, right? So user comes in, tries to upload a file. This file could potentially have malicious content in it. So we need to identify that in real time. So this, in comparing to potentially, let's say I wasn't doing this protection inline and the file was uploaded. Now the next line of defense there could be the API scanning. But again, the API scanning in heavy usage scenarios, is there could be a delay there. So you could have exposure to this file while you're waiting for it to be scanned. So again, the idea here is if you have the ability to put something in line and scan that data in real time and prevent it from getting uploaded, what we're trying to do here is get to a net zero, right? So as I scan your files and data at rest, I want to remove malware. I also want to prevent it from continuing to come in as well. So again, using both modes to kind of give us that zero sum of malware and clean out this application. And then again, there's other things, some other things that are really good for CASB, and, in a best practices scenario is labeling, right? So data classification. The reason why data classification is very important. So even when you're in line and you're doing DLP inspection, whether it's regular expression or keywords or exact data match, that type of stuff requires a little bit more resources. And so there's, in a scenario where we're in line, the application itself is very sensitive in how much time is spent on us scanning that file. So if I have to look for very complex, very, very complex DLP patterns or something like that could potentially take a long time and time out this application, it may be easier to just pre-label and go in and actually scan this data that's already sitting here in the environment and label it. So then all we have to do is actually inspect the metadata. So much easier, much faster. For example, I might have a file in here that has a label in it for CCPA. So I have a user that's logged in. They're not in the group that should be able to access, California restricted, files. And they go ahead and try to download this. And again, we're going to prevent that user based on the label, right? So again, this is just a much faster, much easier for the system to do, especially if you get into complex scenarios. The file itself, just to kind of show you, is just we're blocking it. It's a tombstone file, right? So the other thing here too is some platforms, if you'll notice that, so I have Word open now. So some platforms, Office 365 gives you the ability to utilize something called open. Well, I can show you open in browser by clicking on it, or I could show you open in app. And what this does is actually utilizes a different authentication mechanism. So what we're doing is WebAuth here. What you do is modern auth when you try to use Word. And so if I try to access this and say, hey, just send it to Word and let me work on it there, we need to put some protection around that, right? So again, it's going to say, hey, user, I need to know who you are. So we'll go ahead and do that. And oops, again, I didn't need one of those. And the user is going to go ahead and say, okay, this is who I am. And we're going to say, fine, you are a authenticated user, but we are not going to allow you to open this application locally on your machine. Problem with that, not the problem with that, the reason we want to prevent that is because these were, Word itself uses proprietary protocols. It doesn't like when you rewrite the URLs in a reverse proxy fashion. And it's actually, you can do a lot of this in, in forward proxy as well, but even in forward proxy mode, it's still doing multi-part uploads. It's still doing, a lot of different things that are proprietary and you can't necessarily identify. So really what we want to do is if somebody wanted to access this file here and utilize that local app, well, we want to restrict that to managed devices that are using our endpoint security, and the devices are allowed to have the data there. So that's fine. That's, we'll allow that, but we want to prevent your unmanaged devices from using synchronization tools, Word, things like that, that would be outside of our vision and protection. So, that's an important piece right there that we want to protect against. Any questions on this? I'm going to jump over. Just, I want to make sure I can get a little of the managed device side in here in the time that we have. Any questions before I jump over to the other use cases? All right, let me go ahead and exit that. And so what I'll do here is we'll move on over to managed, and the managed endpoint, we'll talk a little bit more about a lot of different scenarios here. Oops, wrong one. Stop sharing there. And let's jump over here. So this is, I'm going to connect with my Surface. All right, so this is basically going to be the same scenario, right? Well, sorry, not same scenario. This is a Surface, and now we're going to have an agent on here. So now we're going to do things from a forward proxy perspective, from a secure web gateway perspective, and utilizing the power of the DLP engine and identifying different activities. Really, what we want to make sure is this is a managed device given to me by my company, and I have data on here that should be allowed to be here. It has, endpoint security on here, and that's all great. And so from a forward proxy perspective, if I again just go to office.com it should be the same user experience. And so this is something the user would do on a normal basis. Again, logging in here. So we want the user experience to be identical, right? So, well, it looks like I have a cookie. So I guess we'll go ahead and use the cookie. So I already have a cookie. So what you missed there is me going to Okta, right? Which is fine. So now I'm again in here, no rewriting the URL, anything like that, but we're still providing protection for this application. This is a managed application on a managed device. But now I'm still protecting anything this user does and still able to identify when this user tries to do things like, hey, I'm a user that is trying to maybe let's say access a file that I should not be accessing. Again, AIP labeling, same scenario. This user doesn't live in that group, can't download that file. So, we still have that same protection around that, because regardless of if they're on an unmanaged or managed device. But what happens if they download data here and actually try to upload it to a personal account, right? So now we're getting into a scenario where I go out to a personal email account and I move this, and I go out to a personal email account and I want to start attaching files to, email them out, in personal, somewhere that we're not going to be able to necessarily inspect it with like an email gateway or something like that, right? So go ahead and just do a quick login. So we want to put protection around that data that lives on this machine here, and we want to prevent it from being uploaded into an email and being sent out. Now I can also look at the text here as well. So I have the ability to do that. But I'll show you that in a different scenario. So here I'm going to look at the files that live on this device. And I know there may be some sensitive data in here. So we have some social security numbers in a file, and we say, okay, let's go ahead and attach this, right? So we're basically looking at, we're saying that file itself, that we're not going to allow you to attach this. So this file was contains sensitive information and we prevented it. We could just say prevent all files, right? Like, or prevent them from going to email in general. But if you do want to allow allow someone to go to do email on a personal email account here, you can do that. It's just having those protections around that data that they're trying to move from this device up to an unmanaged application. Again, in the same space when we're talking about the SASE, the CASB, the Secure Web Gateway. So, there's parts of this that we're going to do just simple Secure Web Gateway type identification and protection. So let's say, for example, we go to, poker.com. And so user tries to go there. Again, you want to be able to protect you don't want users gambling and things like that. So, incorporating within the endpoint agent here, the ability to do Secure Web Gateway, to do forward proxy. Also, one thing I almost missed as well is, we want to protect our endpoints in general, right? So malicious content, clicking on things within their email, going to malicious websites, maybe being maybe a phishing attack or something like that, something similar to what I have here, right? So if the user goes ahead and clicks on this, we need to identify, the contents of where they're going, right? So we basically said that this is known to be malicious, right? And the actual top level domain itself is not necessarily malicious, because if I go ahead here, Control B there, I can actually get to this location, right? So what we want to do is we want to have the ability to be flexible to allow users to go to SharePoint or some of these locations that are valid domains and locations, but deep within SharePoint or even valid websites, there is malicious content. There are places where malicious content is stored. So you have to do deep level URL inspection to find that. So again, click on this here, and that is the link that takes us to the malicious content. We need to be able to identify that and protect that user. Couple other quick scenarios. Someone going to social media. So we'll just say LinkedIn. So this is where I'm going to start to mix a little bit of DLP, the power of the DLP engine, and identify things and actions that the user is doing, right? And also making sure that my user could be a disgruntled employee, right? What if my disgruntled employee comes in and says, well, I'll fix them, and they go in here and they start typing something, and, we could either prevent them from posting altogether, or I could do this based on keywords. So, this is not a, problem, right? So if I post that, well, that's not an issue at all, right? So post was successful. Very easy. But what if I this time go, this is the word hawk. So now what I'm doing is I'm looking at what the user is doing, and if a word inside of this message actually triggers on a DLP, we want to be able to prevent that. So I'm basically saying that same DLP object that I created that inspects all of my files, that inspects all of my data that I have inside of my managed applications, I'm also now applying that here in the message to make sure that my user, when they go to this website here, that they're not posting things that could potentially be sensitive data in a social media environment. Another cool thing here as well, just kind of a side note, is you see a lot of these likes around here. This could be done for all your different social medias, your Facebooks, your Twitters. Again, remember, this is a managed the device, right? This is something the company gave you. Should you be on Facebook or Twitter, right? So if we do allow that, we don't want you to politically align yourself with maybe a post or anything, because we just don't want that while you're on a work device. So again, identifying when the user does something like that. Well, I want to like this post. Well, we want to block that as well. Sorry, on a managed device, you should not be liking specific things or just liking things in general, right? Just say, sorry, can't do that. We don't want political alignment on that. Do that on your own personal device, on your own personal time, that kind of stuff. So again, the power of CASB is really, it starts at identity, right? And from identity, the next piece that's super important is the DLP engine itself, and identifying all these actions and applying that DLP to scenarios similar to this here. One last use case, which is really asked about from me all the time. So I see this pretty much in every demo. So that's the reason I'll show this here. So we'll go to Dropbox. Box.com. We'll go to box.com. And so let's say Box is a company, it's a sanctioned application, it's a managed app, and that's fine. But your users have their own personal version of Box. And so what we want to make sure is that, yes, they can, when they log in with their credentials that are corporate credentials for the managed application, no problem. They can move data up and down, and we'll inspect it, as needed. But what happens if they log into a personal version of Box? And so I could do a couple things. I could just, block it out, right? I could say, sorry, you can only log into corporate versions of Box. But what I was asked, hey, I want to users have their own personal version, or we acquired a company, and this company's, we need them to access this Box location. I just don't want them uploading data. So in essence here, we're basically making this read only. So if I choose, I believe that's my Box account. That should be it there. Hope that's the one. Should be. All right, perfect. So a couple of things are going to happen here. So there's a couple of things we can do here. So because we're running endpoint, basically endpoint, an endpoint agent here, I can do things like, what if the user tries to download something that is malicious? I don't know if this is the file here. Where's my download? Right there. Okay. Box and Dropbox, they're just always so different, right? So, oops, I hit it double. So hold on, my engine may not be. I have 3 different engines I can scan this with, and this one is not. So they're not picking these up. These are benign. So CrowdStrike isn't necessarily as one of the engines I use. They're just basically saying, you don't fake me. That's fake malware. So they're not triggering off of it. So you saw so we can do this in download as well. So if a user downloads a file, like I'm trying to show here, we actually, you know what? The file that it does trigger on is actually in Dropbox. So, so we can go here. That's right. Because I don't know what those files are in there. So we'll, sign in, and I'll go ahead and log into Dropbox. Because I know this file here, it actually does detect and looks like real malware. So again, it's the same. Never. So we'll go here and all right. So I put a check and we'll say download. So in the download direction, we still want to protect these endpoints from downloading potentially malicious data as well. We can scan the files on download. Yes, there's probably endpoint security on this device. It's managed, but this is just another layer, right? So if you're using, I don't know, Cylance, or you're using McAfee, or using something like that on the endpoint already, another layer would to give you more coverage would to be used another engine, right? So we have 3 different engines. You have Bitdefender, CrowdStrike, or Cylance as an additional layer to provide to what's making it to the endpoint itself. So if we can identify it and prevent it from making it down to the endpoint, then that's great. Just less work that the endpoint has to do. Maybe save some cycles there, right? And then so the last thing I'll show y'all as we get kind of close to time here. I can save time for questions. Let me go back to. I'm going to try to do what I'm trying to do an upload prevention. That's right. I'm trying to remember where I'm at here. So let's go ahead and try to upload any file, right? So we'll just say, it actually doesn't matter if it has anything in it or not at this point. So we'll try to upload a file. So I'm not actually allowing, because I'm logged in under a organization that's not my corporate organization, I'm preventing upload from happening. So I could log into my sanctioned app, my sanctioned version, which is a different domain, and it would allow me to upload, download as is. But this one is a personal version of Box, so allows me in, but doesn't allow me to upload any data. So again, the idea with CASB, it's kind of being stretched into and morphed into, SASE, ZTNA, all these different things. And so at the end of the day, it's all about protecting the data and having the DLP engine and the intelligence from that DLP engine to be able to identify what, the activity that the user is doing, right? They're trying to take data from this device and move it up into personal versions or instances of the applications, make sure we prevent that. Or they click on a link inside of their personal email, or maybe even in any app, or even on the web, and it tries to take them to a malicious location. We want to protect that as well, because again, the risk here is that the data on here is either stolen or credentials are taken and tried to use, which when you start talking about the identity piece of this, we can also talk about the risk of credentials being taken and how to identify, that's a new device this user tried to log in on. So it's a different GUID. So how do I take action on that? So I see these credentials. I've never seen this user ever log in from this particular location. To me, it's suspicious. And because of that, I may want to two-factor this particular user in this instance because they've never done this before. So, as we learn the user's behavior, we want to take action and obviously we want to prevent bad things from happening. So any questions on any of that there? As far as demo, that's all I had to show, but we have the last few minutes here. We can answer any questions for you or something else. Oops. Am I sharing? Yeah, I can't find the unshare. Okay, so I can see my screen, but for some